So Jai Hind everyone. Today I am going to discuss introduction to solar energy. Subject name is Energy Science and Engineering. Subject code is KU033 and KU043. So we will start with introduction to the solar energy. So today, as we see around us, we find major application of solar energy is that we convert that solar energy, that means we convert this sunlight into electrical energy by using solar panel, solar array and all. So basically we will discuss how this functions. Okay, so let's start. First introduction is that solar energy is a radiant highlight and heat from the sun that is harnessed using a range of ever evolving technology, that is the electromagnetic radiation. As we know, we receive sunlight, and that is explained by electromagnetic radiation. Okay, so sunlight we receive in the form of electromagnetic radiation, that is the main concept behind this. Okay, so solar energy, as we listen solar energy, what is the picture that we get in our mind? That solar energy is being used for the conversion into electrical energy. So major application is that. But apart from this also, solar energy can be directly used for the heating purpose also. Okay, so it is important, as it is a free source of energy, so it is very important source of renewable energy, and its technology are broadly characterized as either passive solar or active solar, depending on how we are capturing the solar energy and how we are distributing the solar energy, or how we are converting it into the solar power. Okay, so basically depending on the technology that is being used for the conversion of solar power into the electrical power, so we can characterize as a passive solar or active solar. Okay, so solar energy can be directly used for the cooling, heating, okay, as I told, so drying, distillation, and one major application that we are seeing around us is the power generation, electrical power generation. So earth is receiving 1,74,000 terawatt of incoming solar radiation at the upper atmosphere. Okay, at the upper atmosphere of earth we are receiving 1,74 terawatt of solar radiation. Okay, solar radiation is also known as the insolation. Okay, the solar radiation that we receive over the earth is also known as the insolation. And if we see the global position of all countries, or most of the population is living in the area with insolation level of 150 to 300 watt per meter square. Okay, so that means if we calculate this on per day basis, okay, so it is 3.5 to 7 kilowatt hour per meter square per day. Okay, so that is enough. Okay, but problem is that if we see position of countries across the globe, some countries are in the position that they can harness solar energy as much as they can. Okay, but some of the countries are unfortunate that they cannot harness the solar energy despite of their technology, because their position on the globe is in such a way that they don't receive solar light throughout the year. Okay, so though there is there are many countries those are harnessing solar energy at its potential, according to its potential. Okay, because it is the free source of energy. We will see the advantages and disadvantages of solar energy as well, and I will show you through the picture that how this solar generation is depending on the global position, and how fortunate we are. That means India is one of the leading country in terms of solar energy, and why we are leading, so that I will show you also. See, if this is the solar sun, position of sun, and this is the position of earth. Okay, so in between there is space. Okay, so sun ray is being radiated from sun and it is being received at the earth. Okay, that means at the surface of earth. Okay, so if we see, as we know that earth is rotating, okay, earth is rotating at its axis also, and earth is rotating across the sun also, okay. So if earth is in this position, then this part of earth will be receiving the solar radiation, but this part is not receiving the solar radiation, okay. So as in between sun and earth, we are seeing there is no particle is there between, okay, in between sun and earth there is no particle. So no conduction, no convection is there, only radiation is there. So energy radiated from the sun is electromagnetic waves, which is reaching the planet earth in 3 spectral regions, okay. The solar radiation that we are receiving on the earth can be divided into 3 category, okay. Ultraviolet radiation, visible radiation, and infrared radiation, okay. So ultraviolet is very less, 3%, okay. So frequency, if frequency of radiation that we are receiving is less than 0.38 micrometer, okay, so then it is ultraviolet ray, and amount of ultraviolet radiation is very less, that is 3% only. So next is the visible part, okay. Visible radiation is 44%. So if frequency of radiation is lying between 0.38 micrometer to 0.78 micrometer, okay, if frequency is ranging between 0.38 to 0.78, then it is the visible frequency, visible radiation. And next is the infrared. Infrared is almost equal to visible radiation, okay. So it is 43%. So if frequency is greater than 0.78 micrometer, okay, so then it is known as the infrared radiation, okay. So as we know, between earth and sun there is a large distance, around 1.5 into 10 to the power 8 kilometer, okay. So due to the large distance between sun and earth, the beam of radiation received from the sun on the earth is almost parallel, okay. So this is due to the large distance between sun and earth, that the solar radiation that is being generated from the sun and which is being received at the earth is almost parallel. So here, as we see, since frequency of ultraviolet rays is very less, okay, so more energy is there with the ultraviolet light, okay. So moderate kind of energy you can see is there with the visible radiation, and very less energy is there with the infrared radiation, okay. So if you see the energy level of the different level of radiation, then we see ultraviolet light is having more energy than that of the infrared, and in between infrared and ultraviolet light there are visible light, okay. So here you can see in this picture also that this is the sun, 3% is the ultraviolet radiation, okay, 44% is the visible light, okay, and 53% is the infrared radiation. So here ultraviolet radiation are harmful, okay, because they are having higher frequency than visible light, okay. So visible light are having light frequency, okay, and infrared radiation is beneficial, which is having very low frequency, okay. So this is the picture which shows that how ultraviolet rays in invisible light and infrared radiation are being received by the earth, okay. So here, what is the concept behind the power of the sun, okay. So as we know that sun is having numerous energy, enormous energy, only due to the fusion, nuclear fusion, okay. So over hydrogen is being fused, hydrogen atoms are being fused, and they are generating the alpha particles, that is the helium, and in this process, in this fusion process, enormous energy is being released. That is the reason of the enormous energy of sun. So nuclear fusion powers the sun and all other stars. So this happens in the core of the sun. Okay, so hydrogen or is the fuel of the star, and if we know if we see the fusion reaction, that hydrogen atoms are fused together and they form alpha particle or helium atom. Okay, so in this process energy is being released. So here in between this process, neutrino is a byproduct, okay, and helium is a byproduct also. Okay, so sunlight takes 8 minutes and 20 seconds to reach the earth. Okay, so sunlight travels through the space in the form of the electromagnetic wave or radiation. Okay, so this is important since as we seen, around 1.5 into 10 to the power 8 kilometer is the distance between sun and earth, and it takes 8 minutes and around 8 minutes and 20 seconds. Sunlight takes 8 minutes and 20 seconds to reach to the earth. Okay, see, this is the global energy potential of the sun, solar energy. So total 23,000 terawatt energy, solar energy can be harnessed across the globe. Okay, so but if you see the potential of the tidal energy, that is only 0.3 terawatt. For the wave energy, it is only 0.2 to 2 terawatt. For the geothermal, it is only 0.3 to 2 terawatt. For hydro, 3 to 4 terawatt. Biomass energy, if we harness the biomass energy, it is 2 to 6 terawatt. In case of wind, 25 to 70 terawatt. Okay, and total world energy consumption is around 16 terawatt, but it is not fixed. Okay, as we are progressing, energy consumption will increase. Okay, so we should know that per capita energy consumption is the index of growth also. Okay, in developed country, per capita energy consumption is much higher than that of the developing country. Okay, so per capita energy consumption shows the index of the growth also. So as we will grow, as development will be there, okay, so energy consumption will increase. So this is the if we talk about the electrical energy generated with the help of the coal, so across the globe it is 900 terawatt per year. So by the using nuclear energy, that is where uranium is the source of energy, it is 90 to 30 terawatt per year. Okay, so oil, if we see the oil based power generation, so it is 240 terawatt per year, and natural gas based energy generation is around 215 terawatt. Okay, so this is the global energy potential across the has been shown here. Okay, so this data is changing. Okay, this is not a constant one. So as I told, so since development is going on and it is a continuous process, so our energy consumption is increasing, and our generation is, we are all increasing the generation as well. Okay, so according to the need, we are adding more or more power generation, okay, to fulfill our demand. So now, what are the advantages and disadvantages of solar energy? See, first and most important thing is that if we harness electrical energy with the help of the solar energy, then source is free. Okay, so here it is a free source of energy. Second one is that no greenhouse gases is there. Okay, so there is no harm to the environment. So it is cheaper to use in remote location than running electrical wires. Okay, so if any remote location is there and in that location there is problem, if there is problem in laying out the transmission line and distribution lines, like in hilly area, so in that place solar energy can be harnessed. Okay, as we know, in a hilly area during winter season also sun rises. Okay, and we can harness enough solar energy. Okay, so like in case of Ladakh in India, that is the solar paradise of India. In that place, though there is in cold season also. Okay, so the temperature is very low, but sun shines at its usual time with good potential. Okay, so in that case we need to focus on solar energy for that part. So it is used to it is cheaper to use in remote locations than running electrical wires. Newer technology allow for more efficient energy production. Okay, so as I will discuss that technology is being developed, and solar cells of new technology, that is the synthesized type of solar cells, are being used nowadays, that harness more and more solar energy. Okay, so if we see the in case of suppose efficiency of general if we see the silicon based solar panel, efficiency of that is very poor, but nowadays synthesized kind of material is being used for production of solar cell, and that is giving very good efficiency as well. Okay, so what are the disadvantages of solar energy? That sun is not always prevalent, it is the intermittent kind of thing. Okay, like in winter it is very hard to get solar energy. Okay, so so it is not always prevalent. So pollutants can affect the efficiency of panel. Okay, so pollutants and dust particle, if they are there over the panel, solar panel, then they affect the efficiency. Okay, so that need to be checked at particular time interval. So solar energy can be generated only in daylight. Okay, so we need a storage system along with this solar panel. So weather affects the solar panel efficiency. These are the obvious reasons. Okay, so that's why we cannot completely rely on the solar energy. We always need a backup. Okay, so that may be conventional source, conventional power should be there along with the solar panel, solar energy, as well as there should be energy storage system along with the solar. So these are the solar energy utilization, direct conversion and indirect conversion. Okay, so indirect conversion is that in water energy, wind energy, ocean energy, biomass energy. These are the indirect conversion of solar energy. Basically wind energy is also due to the sun. Okay, wind energy that we are using, that we are producing electrical power with the wind farms, windmills, that is also due to the sun. Okay, so because as we know, wind is only due to the sun. Okay, if sun is not there, wind will not be there. So direct conversion is by using the thermal energy and by using the photovoltaic application will be there for the power generation. And thermal energy application is that process heat application, water heating, drying of food, cooking, distillation, cooling. Okay, so in cold storage also we use the sunlight. And for power generation, that is T greater than 60 degree, low temperature, medium temperature and high temperature. These are the power generation category. So see how some countries are fortunate for having the solar energy, and how some countries are not receiving much solar radiation. This is depending on the latitude position. Okay, longitudinal position of the country across the globe. See here, this is the position of sun, this is the position of earth. Okay, as we know, earth is rotating at its axis, as well as it is rotating across the sun also. Okay, so this is the axial rotation, this is the axial rotation of the sun. Okay, so at this position, sun's ray spread over a narrow area. Okay, and in this position, sun's ray spread over a wide area. At this position also, if sunlight is being incident, so it will be spread over wide area, but the sunlight incident at this direct position, it will not spread over wide area. Okay, so here depending on latitude, heat zones are divided. Okay, so this is the equator, this is the Tropic of Cancer, this is the Tropic of Capricorn, this is the frigid zone at North Pole, and this is the frigid zone at the South Pole. Okay, this is the Arctic Circle in North Pole, and this is the Antarctic Circle. Okay, so here Tropic of Cancer is there at the angle of 23.5. okay, and Tropic of Capricorn towards the North Pole, and towards the South Pole at the angle of 23.5 there is Tropic of Capricorn. So this is the north temperature zone and this is the south temperature zone. Okay, so these are how based on this latitude temperature or heat zones are divided. So inclination of Earth's axis and the orbital plane, okay, in this case this is the equator, okay, so this is the plane of the surface, plane of the Earth's orbit, okay, so this is the here the angle between a plane of the Earth's and this is the 66.5, okay, so the vertical line from the Earth's orbit plane is there, okay, so this is the vertical line, this is the vertical line from the Earth's orbital plane, and the angle between plane of the Earth's orbit and this vertical, okay, so this is the 90 degree and this is the angle, this is the 66.5, okay. So between North Pole, this line, okay, and plane of Earth's orbit, it is making 66.5. See, these are the seasonal changes which affect the solar energy harnessing. So here this is the winter solstice, it is around 22nd December, and here this is the equinox position, it is around 21st March and 23rd September, okay. So during spring it is around 21st March at equinox position, okay. So in summer solstice is there around 21st June, okay. So this in the autumn season equinox will be there in 23rd September, and here again winter solstice will be there around 22nd December. This is how, see here, as you can see in this diagram, here in this part solar radiation will be received, okay. So as you see in this part solar radiation is being received, but when Earth will be in this position, this part will be benefited with the solar radiation, okay. So here during autumn this part is being benefited with the solar radiation. So this is how motion of Earth across its orbit affects the solar radiation. So okay, so now this is the diagram for winter solstice, that is here this is the equator, Tropic of Cancer, Tropic of Capricorn, Arctic Circle and the Antarctic Circle, okay. So when sun ray during winter, this part will be benefited, and see this is the position of the India. So during the winter solstice also India is receiving enough sunlight, okay. So in summer also see only in this part, okay, see this is the Indian country, okay. So this is why India is naturally blazed with the solar radiation in such a way, due to its global position, okay. So we are in such a position that we are receiving the enough solar radiation during the winter also, okay. So see, this is during the summer, this is during the winter, and this is during the summer. See, in this case also this is the our position, and in this case also when here this is we 90 degree, okay. So this is the equator position, Tropic of Cancer, Tropic of this is the Arctic Circle, Antarctic Circle, this is the Tropic of Capricorn. So in this summer also we are receiving enough sunlight, okay. So this is the global position of India, which makes as leading in solar energy harness. Okay. So, when sun's rays strike Earth's surface near the equator, the incoming solar radiation is more, okay, nearly perpendicular to or closer to the 90°. Therefore, solar radiation is concentrated over a smaller surface, causing warmer temperature. See, here solar radiation, Earth's surface is near the equator. See, this is the concentrated solar energy that we are receiving across a small area. So, here the solar radiation is concentrated, and that means it will cause more temperature, okay, warmer temperature than this. Okay. So, when sun is overhead, that is effective solar radiation falling on the surface of Earth is 100 watt meter square, sorry, 1000 watt per meter square into sin 90, because angle is perpendicular. So, it is 1000, okay. But that means when sun is overhead, that means sunlight is falling right angle, at the right angle to the Earth's surface, we will be receiving more solar radiation. But when sun is at 45°, so 1000 watt per meter square into sin 45, so we will be receiving only 707 watt per meter square. So, okay, so this is the sunlight falling at 45° angle to the Earth's surface. Okay. So, this is the angle of insolation and time of day. So, intensity of solar insolation is depending on time of day. During the mid time, we are receiving the maximum solar insolation. Okay. So, this is the no on time altitude of sun and intensity of solar insolation. Okay. So, solar radiation can be categorized into two parts. The Earth's surface receives most of its energy into short wavelength. So, the energy received by the sun, energy received from the sun by Earth is known as the incoming solar radiation and also known as the insolation. So, terrestrial solar radiation and extraterrestrial solar radiation is there. Terrestrial radiation is the energy released by the Earth itself as opposed to the solar radiation that is received from the sun, and extraterrestrial solar radiation is the incident sunlight that is incident outside the Earth's atmosphere. Okay. So, on an average, extraterrestrial irradiance is 1367 watt per meter square. So, this is the picture where heat budget of the Earth's planet has been shown. So, total incoming solar radiation is, if we see, that is 100%. So, some of 51% of that energy is being absorbed by the land and ocean. Okay. So, 6% is being reflected by the atmosphere. Okay. So, 20% is being reflected by the clouds. Okay. So, Earth's surface itself reflect the 4%. Okay. So, then absorbed by atmosphere will absorb 16%. 3% will be absorbed by the cloud. Okay. So, then conduction and rising air will be taking 7%. Okay. So, then total, if we see, radiated back to the space from cloud and atmosphere, that is 64%. Then 6% will be reflected by this radiation directly to the space from the Earth. Okay. So, radiation absorbed by the atmosphere is 15%, and only carried to cloud and atmosphere, that is by through the latent heat in vapor, that is only 23%. Okay. So, this is the heat budget of the Earth. So, here what some basic terms are there, those are associated with solar radiation. So, beam or direct radiation. Beam or direct radiation is the radiation that is directly reaching to the Earth without scattering, without being reflected anywhere. Okay. So, diffuse radiation is the part of solar radiation that reaches Earth's surface after having scattered from atmosphere. Okay. So, total radiation is the beam plus diffuse radiation. Okay. So, total, if we calculate the total radiation, that is the summation of the direct plus diffuse. Okay. So, next is the instruments for measuring the solar radiation. There are few instruments which shows how much solar radiation will be received at any surface, at any earth surface. Okay, so the global solar radiation has two components, direct and diffuse. So global radiation is measured with the pyranometer, and the direct radiation is with the pyrheliometer. Okay, so pyranometer is there for measuring the direct radiation, global radiation is measured with the pyranometer and direct radiation with the pyrheliometer. Okay, so it will be, these devices use two types of sensor, thermal and photovoltaic sensors. So here this is the picture for the pyranometer. So pyranometer is used for measuring the direct solar radiation. Here this is the double glass dome is there. Okay, so here sensor position, this is the sensing portion, this is the guard plate. Okay, so this is made of the glass, these are the leaf. Okay, this is the level adjustment position. Okay, so this is the sensor. So as sun radiation will come over here, the double glass surface, the sensor will sense the temperature and it will, there is some thermocouple. So according to temperature, thermocouple will show the reading. Okay, so this is the structure for the, here these are the wires. So thermocouple, change in temperature in the thermocouple will be reflected by this voltmeter through the change in voltage. Okay, so this is the basic structure, basic working of the pyranometer. So glass dome is the, in the pyranometer limits the response of spectral from 300 nanometer to 2800 nanometer from 180 degree of view. It also protects the thermopile sensor from rain. It is also there for the safety of the sensor that is kept inside the glass dome. Okay, so this construction of the second dome gives extra radiation protection from the inner dome and sensor compared to the single dome. Okay, so that's a double structure is there. Thermopile, as its name indicates, that it is used to notice the change in temperature between the two surfaces. That this is basically a thermocouple. So there are hot wire and cold wire. Okay, so the level active surface is the black surface and the flat and that is exposed to the atmosphere. As according to the temperature, that is the hot, that according to the atmospheric temperature, the level that is there in the atmosphere, that will be warmer and it will be reflected as the change in voltage. Okay, so pyrheliometer is there. This is the instrument for measuring direct solar radiation incident on surface perpendicular to the solar beam. So there are this is the structure for the pyrheliometer. So there are very thin two very thin identical manganese strip is there. Okay, that had been blackened on the surface. This is the manganese strip. Okay, so they have been blackened on the top and are used for detecting the unit of instrument. So one strip A is heated by the, see, this is being heated by the solar radiation. Okay, so this will be heated by the solar radiation, and other is shielded from the solar radiation and heated by an electric wire, electric current from the outside. See, this circuit will be completed and it will be heated through the outside by using the electrical current. So when the temperature of the two are equal, the thermocouple attached to the strips do not generate a current, since there is total compensation. Okay, when the temperature of this manganese strip A and B is equal, there will be no current generation. So in such situation, the amount of heat generated current in the second strip is equal to the amount of heat received by the first strip from the solar radiation, and this will indicate the, see, this is the galvanometer. So when the temperature of this strip is equal to this, there will be no current generation, and this galvanometer will show the zero position. So at the value of the direct solar irradiance can be obtained by converting the compensated current at the time. So if S is the intensity of the direct radiation, so and I is the current, then this is the relation between irradiance and current, that S equal to K into I square. So this is the picture of the sunshine recorder. Okay, so this records the amount of sunshine at any location. Okay, so it concentrates solar radiation through this glass and it records the radiation. So this is the another picture for the same instrument. So this is all about the discussion. So we will continue our discussion with another topic. Thank you.